Hey there, in this video we are going to continue to look at adding and subtracting rational expressions, but the focus here is going to be on rational expressions that have multi-term denominators.
Now when we have rational expressions that we need to add or subtract and they have multi-term denominators, it's a little bit more complicated to think about what the lowest common denominator is. Here we have two that have different denominators, and this one happens to have more than one term. So if we have x over here and x minus 3, whatever x happened to be, these are going to be different numbers. And so what we need to do here is make the denominator x times x minus 3. That's going to be our lowest common denominator because we need both of those factors in there. Let's say x was 10, for example. You would have one denominator of 10, one denominator of 7. If you have a 10 and a 7, your lowest common denominator is 10 times 7, or 70. It may work out that there are numbers that you could make a smaller denominator if you actually knew what the numbers were, but we don't know what x is here. X could be a whole variety of things. So that's all we can do here is say the lowest common denominator that we know of is x times x minus 3, and have both those factors in there to be sure. To do that, we need to multiply each of these by something. This one already has an x minus 3 in the denominator, so we need to multiply it by x over x. Again, x over x is just equal to 1, so you're not changing this when you multiply by x over x. You're just writing it in higher terms than the original. The bottom I've already got there, x times x minus 3. The top is going to be x times 2x minus 1. Now, it might look like I should write it like this, x times 2x minus 1, but what we're going to want to do after is add it to what's over here. So to do that, it's going to be helpful to have it multiplied out. So I'm actually going to write it as 2x squared minus x. For this first fraction here, I'm going to need to multiply by x minus 3 over x minus 3. So the bottom I've already got there, x times x minus 3. The top is going to be x minus 3 times x plus 4. I'm going to multiply that out. I'll need a bit more space there because this is going to be x squared minus 3x plus 4x is going to be plus x minus 12. Once I've rewritten my two fractions like that, they're equivalent to what I started with. They're just in terms where they have the same denominator. I can write it as one single denominator. I'm just going to, for now, leave the denominator in factored form because I'm not going to need to do anything with that. On the top, I'm going to add things together. I have x squared and 2x squared, so that's 3x squared. I also have x plus negative x. X plus negative x just cancels out, so I don't even need to put anything there. And then I have also a minus 12, so I'm going to put minus 12 there. Now, this is fine to leave like this. If you don't like it that the bottom is factored and the top is not, you're welcome to factor the top so it matches, or multiply out the bottom so it doesn't. Like you could leave this as 3x squared minus 12, and you could make the bottom x squared minus 3x if you want, or you could factor the top. If you factor the top, there's actually a couple steps of factoring because it would be 3x squared minus 4, and then the x squared minus 4 could be x plus 2, x minus 2. So if you wanted to, you could make it that over x minus 3. It's not a bad idea to do that because it may well be that you have some common factors. Any one of those three things that are circled there are fine. All right, let's get this out of the way. Now before we leave this one, it's worth pointing out kind of a common error people make. Oftentimes people will say when you have x and x minus 3, the common denominator is x minus 3. But again, just like before, you can't represent part of a binomial as an entire factor like that. So x and x minus 3, you need both of them there. You can't just cross off, and if it was x over x minus 3, you can't cross off part of it. So just like that, they're different things. And so they're different things here, meaning you need both of them in your denominator, so you would need both of those there. For this, we have x plus 2, x plus 6. Our common denominator is not x plus 12 or anything like that, because again, these are two different numbers. If you're ever not sure, just think, what if x was, and pick a number for x. Let's say x was 1 here. this would be 3, this would be 7. Those are two different numbers. Common denominator is not 12 or anything like that. You need both of those factors. You need both of those factors there. So the common denominator is going to be x plus 2, x plus 6. So I'm going to write both of those fractions with that denominator, x plus 2, x plus 6. To do that, I have to multiply by, on this side, x plus 2 over x plus 2. And this one I have to multiply by x plus 6 over x plus 6. So then if I figure out what I have on the top here, this is going to multiply out to x squared plus 6x plus 4x is plus 10x plus 24. And then my other side here is a little bit easier. That is going to be x squared plus 2x. Now the fact that this is a minus here is going to be pretty important when we're putting this all together. If I write this with one denominator here, x plus 2, x plus 6, I won't bother multiplying that out again because I don't know whether I need to do anything with that yet. I'm not adding it or combining it with anything else. I have here this, take away all of this. If I'm going to subtract this x squared, I'll do it one term at a time. X squared minus x squared adds to 0 or subtracts to 0, so I'm just going to leave that. I'm not going to write anything. After that, I have 10x minus 2x minus positive 2x there. It's minus this whole thing, right? So you have to imagine there's brackets around that. So minus 2x. 10x minus 2x is 8x. And then my last thing there is this 24. There's no term that goes with it over here, so it's just minus 24. 8x minus 24. This is not in factored form. This is in factored form. And as we had over here, you're welcome to write it either by multiplying this out, or leaving it like this, or writing that top in factored form. It's, again, not a bad idea to write the top in factored form, because it's always possible that you have a common factor that you could reduce once you've added or subtracted. That top is actually 8 times x minus 3. So there is no common factor to get rid of, but again, worth checking. Either one of those. Okay, let's look at a couple more. All right, this we're actually adding 3 things together here. This one might disturb you a little bit, but just like when you're adding fractions, you can think of this as having a denominator of 1 to write it as a fraction. Now, you might think this and this are different. We need to include both of there. So you might think the common denominator has to be x squared minus 4 times x plus 2, but that's not true because this actually can be written in factored form, and you'll see that it does have something in common with the other thing here. This actually can be written as x plus 2, x minus 2. So actually, this denominator already has this as a factor, so you don't need to change this fraction because it already has those 2 factors. The ones that we are going to need to change are these ones over here. So our lowest common denominator is going to be x plus 2, x minus 2. So it means I'm going to need to multiply this by x minus 2 over x minus 2. Hard to squeeze in there, but that's what I'm going to need to multiply it by. And then this thing, I'm going to need to multiply by both of those. So I need to multiply by both of those. I could just write x minus 2, x plus 2 over x minus 2, x plus 2. But now that I've already written it out, this might seem silly, but instead what I'm going to write is, since I know that that's what it is multiplied out, just to keep things shorter, I'm going to just say I'm multiplying this by x squared minus 4 over x squared minus 4, because that's what that is. My common denominator is x plus 2, x minus 2, or in other words, x squared minus 4. So I'm going to leave this one like this. I'm going to multiply this out and see what I get. I've got x times x minus 2 on the top, or x squared minus 2x. On the bottom I have x plus 2 times x minus 2, which I already know is x squared minus 4. Might as well write it in that expanded form because it's shorter. And then my third thing is going to be x squared minus 4 over x squared minus 4. Because it was 1 to start with, so it's something over itself. Makes sense. If I add all of that together, I can write it as one single fraction and simplify everything on the top. If you want to write it as one single fraction first, you can, or you can actually just look at it and add as we've been doing already. I think for this one it might make sense to write it as one single fraction before trying to put terms together, even though they're all adding, so we're not going to run into that subtraction problem over that single denominator there, x squared minus 4. Putting that together, I have x squared plus x squared, so I have 2x squared. And I have x minus 2x, which is actually minus x. And then I also have plus 3 minus 4, so it's actually minus 1 over x squared minus 4. You could try and factor this if you want to. You'll actually find that if you factor it, this thing is equal to 2x plus 1, x minus 1. If you multiply those out, you get that. On the bottom, as we had up before, this is x plus 2, x minus 2. As you can see, there's no common factors, but it's either way is fine, that or that. They're equivalent to each other. All right, let's look at that last one. I'll just create a bit more space for myself here first. Now, just like the one before, we're going to need to look at what this is in factored form to see whether it has this already as a factor or whether we need to include both of those things. This in factored form, let's look at it over here, is actually x plus 3, x plus 1. If you check, that multiplies out. So it actually already has x plus 1 as a factor, same as the first fraction. So this already has the common denominator that we need, which is both of those things. So in this case, I'm going to leave it written in factored form. So we have our two fractions here, and we need it to have x plus 3, x plus 1. That I'll just leave as x minus 1. We don't need to multiply that one by anything. This one we need to multiply by x plus 3. Squeeze it in there, x plus 3. If we have x plus 3 times x, we're going to have x squared plus 3x. On the bottom, we'll just write it the same way, x plus 3, x plus 1 as the other fraction. If we subtract that, I'm going to write that as a single fraction here with this denominator, x plus 3, x plus 1. And I have x squared plus 3x. I have minus x. And I have minus negative 1, which is plus 1. Important to notice that when you're subtracting. If I want to write that in simpler form, I have x squared plus 3x minus 1x is plus 2x plus 1 on the end over x plus 3, x plus 1. Now, as I said before, you can write these in expanded form or in factored form, but it's worth writing them in factored form if you can to see if there's any common factors, because this one actually has some common factors. If we look carefully here, that numerator can be written as x plus 1, x plus 1. The denominator is, of course, x plus 3, x plus 1. So actually, we can eliminate one of those factors and just be left with x plus 1 over x plus 3. That x plus 1 is a common factor, and you can reduce it just like any other rational expression that has common factors. All right? So that's a look at adding and subtracting rational expressions where you have denominators that have more than one term, multi-term denominators.